Alright, from the top of a 100-foot tall air traffic control tower. So let's draw it. This is 100 feet. From the top of, so kind of like right there, an airplane is observed flying towards a tower. So this is 100 feet, and the person controlling it. If the angle of elevation of the airplane changes, so we're going to see an airplane. (32 degrees). Airplane. Changes from 32 degrees to 10 degrees. So this angle here is 10 degrees. So that last one, 32 degrees, is that. During the period of observation. Now, I did it again. I made the same mistake last period. Do airplanes just go down? Well, they fly kind of diagonal, so it's both a vertical and a horizontal. So I only showed the vertical, so I should have shown airplanes like right there. I do mind a pen to help you, so I don't have a pencil. Goodbye, airplane. If the angle of elevation of the airplane changes from 32 degrees, right? Coming in, it's going towards landing, to 10 degrees during the period of observation, so you're watching it, and the altitude of the airplane, so altitude is just another word for height, or vertical, right, the vertical of the airplane changes from 500 feet. So I'm assuming the height from where it's at, that's 500 feet, changes from 500 feet to 200 feet. So now here, that's 200 feet. How far does a plane travel horizontally? I added that word horizontally because you could argue, well, it has, are you talking about this distance, that distance, this distance, and so we just want to know that horizontal distance. So how far does the plane travel horizontally? It's here, and I'll call that X. Now, I'm going to go ahead and draw two triangles, and we're basically going to solve the two triangles. So let's go ahead and do the pink. So I have this pink triangle here. Now, the only thing I have is 10 degrees. Remember, the airplane is 200 feet in the air, but that's not the triangle. The triangle's up here. But the control tower is 100 feet. Does that make sense? So this is 100 feet. 100 plus something equals 200 feet. Therefore, this one is 100 feet. I'm going to introduce a new variable to the problem. I'm going to call this y. Y is the distance that the airplane at its last observation is before it goes to the tower. So I'm going to call this y. So what I'm going to do is I'm going to solve for y, and then I'm going to solve for the big triangle, and if I subtract y, that'll give me the distance of x, and that's the distance traveled. So let's go ahead and solve this problem here. From the angles where I start, you can either circle or highlight it. I go across, I have the opposite, I have the adjacent. In class, we're going to use which trig ratio? So I have tangent of 10 degrees equals the opposite over the adjacent. Therefore, tangent of 10 degrees is equal to what? 100 over y. We can make this over 1 and just cross multiply. Now I have y times tangent of 10 equals 100. We're trying to solve for y. All I have to do now is divide by tangent of 10. Now I'm going to leave my answer in two ways. Here I have a calculator-ready equation, 100 divided by tangent of 10. And I'm also going to put that on my calculator, so I'll get on my calculator. Make sure I'm on degree mode. I'm going to do 100 in parentheses divided by parentheses to show the denominator tangent of 10. I get 567.13. So what I've solved so far is a variable y, and y is just this here in blue. So we're trying to solve for this yellow, and I have to solve for one triangle. That's the smaller triangle. Let's now get an equation for the big triangle. If I draw the big triangle, class, how many degrees is it?
32.
32 degrees. I have a right angle. Class, is this side going to be 500?
No.
How much do you think it's going to be? Yeah, the control tower is how much?
100.
100 plus something equals 500. So if this is 100, class, how much is this going to be?
400.
400. So the bottom length down here is y plus x. If I add the distance of the blue plus the yellow, I get the whole big triangle there. Okay? And then eventually we're just solving for the variable x, that's our answer, but when I need it, I can put in y. Okay? So let's go ahead and get a trig function. Class, what side do I have? And this side?
Adjacent.
So I'm going to have the tangent of 32 degrees equals, which two sides, class?
Opposite or adjacent.
Tangent of 32 degrees equals, how much is my opposite side? 400 over my adjacent side?
1 plus x.
Now here, I want to put it in parentheses. I don't want you to separate this. Let's get the equation to solve for x. Let's get where it says x equals. So we're going to do the same thing, put it over 1, cross multiply. So I have 400 equals tangent of 32 and y plus x. Everyone say distribute. I'm going to distribute here. So I have 400 equals tangent of 32 times y. Does that make sense? That's the first one. And I just put the variable in front. And then I have x times tangent of 32. class, what variable are we trying to solve for? Alright, so let's get this x by itself. So I'm going to move this y variable to the left side. So I'm going to divide both sides by y, tangent of 32. These will cancel. And now I'm left with 400 divided by y tangent of 32 equals x times tangent of 32. Okay, my goal is to solve just for x, so now I'm going to divide both sides by tangent of 32. Now pay attention. If I divide this side by tangent of 32, dividing by, so this should be in the denominator. On this side, it should also be in the denominator. You see that? So my grand equation right now is, I'm just going to switch sides so it looks kind of pretty. X equals, what's in the numerator? Just the 400. I have a y times the tangent of 32 squared. You see that? Because it's tangent of 32 times tangent of 32. Uh-oh. Where's that y from? Over here. Do you see it? So this y variable now I can substitute it back in. So my equation is going to look like this. (400) divided by 567.13. That times tangent of 32 degrees squared. Alright, let's take out our calculators. Alright, I want to be extra careful if I'm going to go for the home run. The home run is I just put it all in the calculator and press enter. To do that, I'm going to make sure I have my lots of parentheses. So 400, I'm going to put in parentheses, close parentheses, divided by, this parentheses is showing everything in the denominator. I'm going to open another parentheses for the 567.13. Uh-oh, made a mistake. Go back, just press delete. I close the parentheses. I'm going to open another parentheses and write tangent of 32. Close parentheses, that's closing the degree. And if I put one more parentheses, that's closing the tangent, the trig, and then I'm going to put the power of 2, and then close one more parentheses. So if you think about it, I have 3 parentheses for the denominator, open ones, and then 1, 2, 3, 4 open parentheses, and then 1, 2, 3, 4 close parentheses for the denominator. Ready? Oh no, that's not the answer. Let's go back. The answer is 73. Did anyone get 73? No. Alright, so let's look back at our work. (10 degrees). This is 100. Tangent of 100 over y, cross multiply. 100 over tangent of 10. Check that one. 100 divided by tangent of 10. 567.13. Yeah? then I have the big triangle, 32 degrees, which is the opposite side. The opposite side is 500 minus the 100, which is 400. And the length is y plus x. So the opposite of 400 over y plus x. It's okay so far? I'm just double checking my work because I'm trying to make a mistake somewhere. I'm going to cross multiply tangent of 32 y plus x times 400. It's fine. I distributed the tangent of 32. Okay, I'm trying to solve just for x. Divided both sides by y times tan 32. So just 400 times y times 32. And then I'm dividing both sides by tangent of 32. Let's try this back here. Instead of typing in tan 32 squared, I don't have history on mine. Can they go up? I'm going to type in 400 divided by 567.13 times tan 32 times tan 32. Let's see if that works. 400 divided by 567.13 times tan 32 times tan 32. Oh, another wrong. Ow. I know I made a mistake. Ran out of paper. Right here. When I distribute, so if you did something like 2 times y plus x, class, what do you get?
2y plus 2x.
So that should have been addition right here.
I was going to ask that.
Let's go back and fix it. Again, I use pen because so you guys can see it easily. So let's go back. 400 equals tan 32 times y plus x. Class, if we distribute, what do you get? What do I get? Y times tangent of 32 plus x times tangent of 32. Instead of dividing, like the mistake I made, we're going to, we're trying to get x by itself. So I would subtract all of this. It's kind of lumped together. Do you see it? Whoops. So I now have 400 minus y times tangent of 32 degrees, that's kind of in the parentheses, equals x times tangent of 32 degrees. Class, what variable would you solve for? So what do we need to do next? Divide by tangent of 32. And I can cancel over here. Now be careful. The temptation is for you to want to cancel these because you see something that's the same just like we did over here. But here this is multiplication and here this is subtraction or addition. So you can't do that. Okay, So my big equation so far is 400 minus the y variable. The y variable we got from over here, which is 567.13. Now let's put that in. 567.13 times tangent of 32 degrees, and all of that we're going to divide by tangent of 32 degrees. Now, here it is okay to simplify by parts. What do I mean by that? 400 minus, I'm going to do 567.13 times tangent of 32. And I get 354 point. And notice how if it did tell me to round, I'm actually not going to round. So look how many decimals I wrote. I wrote them all out. And then I'm just going to have the tangent of 32. Again, you can go for the home run, but it's okay if you do it in parts. Now I can put that in my calculator. Now that I solved my mistake. Good strategy that I made a mistake in front of you is you can see how I actually went back, right? And I'm looking through. That's something you're gonna do. 400 minus 354.32155, and then you're going to divide that answer by 0.624869359. Again, you could have gone for the home run, which is totally fine. So satisfying. There's my answer. My answer is 73 feet. So let's go back. Let's talk about my mistake over here. So over here, all of that was incorrect. And the distance that the plane traveled here to there, right, is the answer is 73 feet.